Hey guys, how you doing? So today we are going to solve this problem called first missing positive. It's lead code 41. It's a hard problem and was asked at Amazon, Microsoft, Facebook, Uber, and really good companies as you can see in this list given below. So without further delay, let us jump into the problem. So given an unsorted integer array nums, find the smallest missing positive integer. So let's take this example. So it's given that 120. The first missing positive integer is 3 because 3 is not present in this array. 1 and 2 are present. For this example, it's 3, 4, minus 1 and 1. We see that 2 is not present in this array. So the solution is 2. For this array 7, 8, 9, 11, 12, the first missing positive integer would be 1 because 1 is the first positive integer and it's not present in the array. So I'll jump to whiteboard quickly and let us understand what and how to solve this problem. So as you can see, we'll take the example 3, 4, minus 1 and 1. Uh, Now minus 1 is not something that we need to be concerned about because it's not a positive number. So we can like literally ignore that, or what we'll do is create a hash table. And what is this array? Size of this array? It's 4, right? So n is 4. So we'll initialize the 4 elements that are the first 4 positive integers. So 1, 2, 3, and 4. And they're initialized with false initially because we have not uh, because we are assuming they are not present in the array. So we started reading the array and we see that 3 is present in the array. So you mark 3 as true. Then we see that 4 is present in the array. So we mark 4 as true. Then we find minus 1, and minus 1 is not a positive number, so we can ignore that. Then we find 1 is present in the array, so we mark true. Now we can start iterating from 1 and we can keep on going from 1 and we can check if that number is present in the array. We'll do I plus plus and we find that 1 is present in the array, so it's not the number. So we go to the next one. 2, it's not present in the array. It's because it's false, right? Since it's false, the answer would be 2. So that's an approach of solving this, but the problem is that the time taken would be big of n, that is linear, but the space taken is also big of n, that is linear, because this hash map we have used would take up big of n space at post, right? Because let's say, because you can see this example only, we are using 4 space, so it's a linear extra space we are using for the hash map. So there is a way to optimize on this, and we can literally reduce the time space complexity. So we'll just have a look at how to do that. So the thing we have to understand is what we are trying to do with this hash map. We are trying to achieve if an element is present or not. We are trying to understand that. I mean, we are storing that in the hash map. Instead of storing that in the hash map, what if we could store that in the array itself without using any extra space? So let us understand this once again. We have 3, 4, minus 1 and 1. Now, what if we could mark that 3 is present somewhere in the array? Now, the first thing to understand is that minus 1 is not something we need, so we'll just filter that out. We'll keep the positive numbers only. So we have 3, 4, 1. Now, to mark the presence of 3, we'll negate the position 3, that is 1, 2, and 3. To mark the presence of 4, we don't have to mark it because it's already out of bound, because in this array we have 3 elements and 4 is going out of that, so we don't need to mark it. But for 1, and you can see the 1 is here, so we'll mark this position as negative. Now the array we have is minus 3, 4, and minus 1. you will use the previous technique, that is start I from 1 and keep on doing I plus plus. We see that 1 is present because the position is negative. Now sign is more important to us, so we'll check the sign and it's negative, so 1 is present. We check 2, 2 is positive, this is a positive, so the answer is 2. That means 2 is not present in the array. So we'll use this method to um, find out what is the first missing positive number. I'll write down the algorithm here. So the step one would be to remove all negative and 0. Now the step 2 would be marking the presence that are present, marking the numbers that are present by negating the indices of that position. Once that is done, in step 3 we'll go and iterate the entire array once again with I is equals to 1 and do I plus plus, and we check if array of I is greater than 0. If it is greater than 0, then you return that I. Otherwise, keep on doing I plus plus. So that is the entire approach, and we are not using any extra space in that. So the time complexity for this would be big of n, and the space complexity would be big of 1. Now we'll jump into the code, and the first step would be to remove the negative numbers from this. So we'll use a positive array and we'll iterate the given array. Then if I is greater than 0, we'll just add it to our array. And finally, this array POS has all the positive numbers, so we'll mark it. So we'll just use num equals to pos so that I can use that element throughout the array, or we might not even do that, but let's say for ease, these are the positive numbers. Next, what we're going to do is for I in range length of the array, we have to mark the elements that are present. So if nums of I, is less than or equals to length of the array, right? If it's less than the length of the array, that means we can basically work on that. Otherwise, it would be out of bound. So we'll do absolute because we are marking the element, the negating the elements in place. So we'll use absolute, and we'll take the number n as absolute of what we are searching for. So nums of I, and we are going to just simply negate that. So nums of n minus I is equals to minus 1 into absolute of nums of n minus I. That's it. Why we are doing n minus I, n minus 1? N minus 1 is for the indexing of that. The number is 1 based, but the index has to be 0 based, right? That's why we are doing minus 1. Once this is done, we have already marked it. Now the third part of our algorithm is check the number that is the first smallest positive, right? So while I is less than equals to length of the array, because we don't need to go beyond that, right? We'll just do if a of if nums of I minus 1. So if that number is greater than 0, according to our algorithm, if it is there, then it's going to return I, and we are going to increment that otherwise, and then return I. So that's the code for the solution, and I'll try submitting this. So as you can see, we submitted this and we got 32 milliseconds time taken, and the space taken is also 97%. And we can see that the approach is completely linear, and we have not done any quadratic or more than linear operations. So this is also linear, this part is also linear, this part is also linear. So the time taken is big of n, and the space taken is big of 1, since we're not using any extra space. That's it for this video. Hope you guys enjoyed this and it's helped you. Do please consider hitting the like button and subscribing to the channel. So we share problem videos and we solve problems online, and you can also suggest me problems that you want me to solve live. And that's it. Hope you guys enjoyed this and this helped you. So this is a very important problem for coding interviews. And until next time, take care, keep enjoying, keep interviewing. Thank you.